Welcome, students, to another optional video to help you with your work. So on this assignment, you have various things having to do with inverses. So find the inverse of each function. This one you're going to switch x and y and then do reverse PEMDAS. So let's do number, I'm going to be nice. Let's do number 4. Let's do the tough one together. So remember, j of x is really just y, so you can go ahead and put y there. And then we have to swap x and y. So I'm going to do that over here. So I have x equals 3y plus 1 over 6. Now when you have a fraction and you're trying to get a variable by itself, I recommend multiplying that by the denominator to clear it out. So we're going to multiply both sides by 6. So I have 6x equals 3y plus 1. Well, now we can continue with reverse PEMDAS. So do I have anything I can add or subtract to get that y alone? Well, yeah, I have this plus 1 I can get rid of. So minus 1, come back up here. So I have 6x minus 1. Be careful, don't make that 5x. You're not subtracting 6x minus x. There's 6x minus 1, and you don't know what x is, so you can't combine those. And then equals, these cancel out, 3y. So add, subtract is done. Can I multiply or divide anything? Well, sure, I have this 3 times that I can get rid of. So divide both sides by 3. So then you get y equals 6x minus 1 over 3, and that's your inverse. So that is j inverse of x. So 5 and 6, you're doing the same thing. You're just graphing the inverse afterwards. And make sure that when you graph it, remember the mirror. This line, y equals x, is your mirror when you have inverses. So make sure that your graph, your lines, reflect over that. Use composition to determine whether each pair of functions are inverses. So composition, you're going to be putting one equation inside the other to see if you get x back. So what I would recommend here is taking a few points. So let's take a few points. Let's do 7. No, we're doing number 7. So x and then g of x, and then x and then f of x. So just pick a number for x for this one. I'm going to pick 2. So plug 2 in here. So I have negative 5 minus 7 over 2 times 2. And notice that's the number I picked. So I just picked whatever x value I wanted. You can pick anything. I just figured 2 because I would cancel that out. And I get negative 12. So now I'm going to put negative 12 back into here. So I'm going to put negative 12 into this and see if I get 2 back. And if I do, and if it happens twice, we're going to try it twice. If it happens both times, then I know I have an inverse. So now I'm going to take negative 12, which is the answer I got here, plug it into this equation, and see if I get 2. So 2 over 7 times, and then remember I'm using this number for my x, times negative 12 minus 10 over 7 is in fact 2. So remember when the notes talked about tables of inverses that x and y switch? And notice that that did happen. So that's a good sign. Yay, we probably have inverses, but let's just be safe and try it once more. So I'm going to pick another x value. In fact, you know what? Let's be super easy and pick 0, because why not? Let's pick 0. So negative 5 minus 7 over 2 times 0 this time. I get negative 5. And then I'm going to put negative 5 into this equation and see if I get 0. So negative 2 over 7 times negative 5 minus 10 over 7, and I get 0. So notice that these two functions have their x's and y's swapping places, so that means yes, they are inverses. So that's what you do on 8 and 9. And then on the back, you're just saying, are they inverses and how do you know? So remember, when you have a graph, you want to look for this line y equals x. You want to look for this to be your mirror. And then I would recommend actually turning your page. So here's my mirror. Does it look like F is looking in the mirror and seeing G? Like they're reflecting each other? Well, yeah, like here's F. He's like facing the mirror this way. G is looking back the other direction. So yes, they are reflected across the line y equals x. So yes, because they reflect over y equals x. So be real careful. Let's do one that's not. Oh, this one. So this kind of graph fools a lot of kids. They think that because one is positive and the other is just a vertical reflection, that they are inverses, but you're not looking for a vertical reflection. You're looking for this diagonal reflection, like that. So if I turn my paper like this, does it look like this function is looking at itself in the mirror? Well, no, because its reflection in this mirror would be here. And it's not, it's down here. It's like reflected and upside down. So no, because they do not reflect over y equals x. So try the other 4 of those, and then at the bottom, remember you are looking for if the old x's become the new y's, and the old y's become the new x's. And I'm not going to give either of these away, but just check them. See, do these match these, and do those match those? Similar here, do these match these, and do these match these? And that's what you're looking for.